Hi, how are you all? Welcome to IGBits. We train, you learn. How is preparation get going? Have you re-reviewed yesterday discussion? So be a practice of actually re-reviewing them on a quick note, and also do your best on the looking at more problems and then understanding a strategy to solve the problem is very important, and this is essential for this point of time. Okay. I am keep repeating the reason is like you have to be remember of what you are doing, and then good start is of success, is it? So you are already in success journey. I'm sure you will be able to reach the, the destination that you wish for. Okay, so today we are going to look at some of the problems related to the graph, 1D graph, 2D graph, and the few exam questions also we can look at. Okay, without further delay, let's get started. Motion in a straight line, graph problems, 1D, 2D. We created a YouTube channel. Which does that our YouTube channel at the rate IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah. Thank you. Let's look at formulae for uniform acceleration motion that we have seen in last class. We talk about a straight line motion and vertical line motion, right? In a straight line, we have four formulas: v is equal to u plus at, s is equal to u2 plus half at square, v square minus u square equal to 2as, s and equal u plus f 2n minus 1. Isn't it? For vertical line, we have two cases: upward direction and downward direction. In case of upward direction, acceleration A equal to acceleration due to gravity g, A equal to g, positive value. So if you can replace A with g, then you have the all formulas as is, right? V is equal to u plus gt, s is equal to ut plus half gt square, v square minus u square equal to gs. So whereas downward direction, vertical motion in downward direction, in this case acceleration A is become like a minus g, minus acceleration due to gravity. Then all the formulas becomes v is equal to u minus gt, s is equal to ut minus half gt square, v square minus u square is equal to minus 2gs. Okay, if you remember, I think you will be able to actually attempt some of the problems. Okay? Solving is much easier for us. Now let's look at non-uniform acceleration motion. We studied, right? We studied non-uniform acceleration of the motion. So can someone recap what we discussed? You're right. So in non-uniform acceleration, we are saying that uniform is not a constant, it is a variable. Good. The same thing I captured here. Let's look at the motion of an object in which the object travels at a different speed. When I say different speed, what does it mean? When I say different speed, that means it does not cover same distance, does not cover same distance in equal time interval. Right? That's the definition. So I'm reiterating, when motion of a particle is not uniform, the acceleration of a particle is not constant. That just means, so then it's a variable, right? The acceleration should be a variable. It is a function of time. If you look at this graph vt, we see the curve. So in non-uniform motion, the velocity changes irrespective of time change in time. So the graph will have a curved line, right? So whenever you look at a curved representation, that is a non-uniform motion of an object. So the slope of velocity time graph depicts the acceleration dv by dt. That's the slope, right? Change in velocity by change in time, what you get a slope. This slope is nothing but your acceleration. For solving non-uniform acceleration motion related problems in one dimension, these problems are, these formulas are hold good. You have to remember them. So let's look at v is equal to ds by dt. By definition, v is nothing but what? Change in displacement by change in time. ds by dt is nothing but v. So cross multiply, you get v dt equal ds. ds is equal to v dt. Now look at acceleration. So what is an acceleration? A is equal to dv by dt. So by definition, change in velocity by change in time is nothing but acceleration. So let me rewrite it. A equal to dv by dt, right? So let's multiply ds by ds. Then you identify ds by dt is nothing but v. Can you rewrite? You have to rewrite this is v and then dv by ds. Correct, no? Is called a. So now cross multiply a into ds equal to v into dv. This is another way we can relate. So these relationships are very helpful for you to solve the one-dimensional non-uniform problems. Are you clear? Good one. Next problem. Let's look at my screen. Do we observe the time variation of position in nature as shown in the graph? This was given in bits 2009. Basic concept related problem. If you understand the position and time how they vary, you will be able to figure out the answer at first place. Some of you already answering. Good. Keep up your good work. But let give a chance to others to answer this. Alright. Yes, you're right. So basically we are talking about this is a position and a time graph. So the position is keep increasing, right? But time is what happens, like sometimes increasing and after that is decreasing. In real time, the t is always like going forward direction, right? Increasing order. So till this point of time, I think you are expected to see that both are actually increasing, position and time. But after some time, even if x increasing, the time is actually decreasing. I don't think this is going to happen, is it? The time is always like kind of increasing, right? It's not decreasing order. So that's why this is never going to happen, guys. So obviously answer is B. Are you clear? When you are here, let's say you are walking. So your distance is going. So your displacement or distance whatsoever, this is keep increasing with respect to time. Just move like this. So t never becomes like a lesser value, right? Sure. Next problem. In a given xt graph, these are the four possibilities. You have to tell me like which one is correct. This is xt graph, yes, the position time graph. We have points A, B, C. Let's understanding each option and then you can choose the right one. What is given in A? The velocity at A is 0, but B is not 0. First thing that you have to understand, how do you get velocity? Velocity is nothing but ds by dt. So this is nothing but a slope of the curve, slope of the st curve, st or xt graph. Agree? So if you look at a slope, he is talking about only A and B. So this is the A point, this is a B point. This is a flat, right? ds by dt would be here 0, here also 0. You agree? Because of constant, right? Differentiation of a constant is nothing but your value, that is 0, right? So the velocity A is 0 but B is not 0. So this is the wrong answer. The velocity A and B are 0. So probably this is the right answer. Let's look at other things also. Velocity at A and B non-zero. No. Absolutely 0. The direction of velocity at A and B are definite. Kya direction? We are talking about a 0. Again, you can see the start increasing order here. But at point A, we have 0 velocity. It's kind of like a rest point. Okay, so the answer is B. The keynotes of the position versus time graph. You can take away these points. We can apply them when we are actually looking at a graph problems. In a case 1, so what is happening with respect to time? If you look at your x graph is actually the red line, right? It is on the x-axis. So line is at the bottom. When you look at this one, what you understand, object is at a starting point, because with respect to time you are at x equal 0 position, right? So line, if the line is at the bottom, that means the object is at a starting point. You got it, right? Now look at this one. If you started moving from starting position, that means like time is increasing and the x is also increasing. Let's say for example you are going to office from home. What happens? You are going away from home, and then your time is increasing, your distance from home is also increasing, right, at some order. So when you look at this kind of a graph, that means like the object is getting further from starting point. This is how you can look at line is going upward direction. Okay, in other case, if the line is going downward, what that means is that so probably you are actually going back to home, object is getting closer to the starting position. So this graph is like x and time, right? The position and time graph. Y-axis is the position, x-axis represents the time. Now look at, if at all you have to see, you happen to see there is a straight line like this, not on the time axis but above the time axis. If you see this kind of, what this means, like at particular instant object is not moving, it is in rest. Clear? Any question? So you remember, this is a x and this is a t. So we are talking about, this is a line, right? So line is at a start point. That means like we are at a starting point. The object is at a starting point. So you can easily notice these things and then identify, okay, what is happening in the graph. When you see this is like inclined upward direction, that means like the object is getting further from start point. So we are moving, right? This boy is moving, kind of. When it is a downward direction, that means you are coming back to home, starting point. This is nothing but your rest, yet rest. Okay. Since you have seen the few tips in identifying nature of the object in its motion, now you can actually start identifying them in this graph, the position time graph. Okay, y-axis we have a position in meters, x-axis is time. So you can see this one, 0 to a position, it is like graph in increasing order, the positive direction. So you are going away from starting point. That is how we are seeing, right? The other one is like B to C, the negative direction. If you look at, I think your distance is actually decreasing with respect to time. So you are coming back. It's a negative direction. Both positive direction, negative direction. If you look at, I think that if you look at this line, so it's a constant velocity. So slope is constant. So dx by dt is constant. It is dx by dt is like your velocity. Okay, and then this is a to b is a flat line. Means like object at rest within this interval, whatever may be 30 minus 10, 20 seconds, object is at rest, right, in this interval. So from B to C again coming down with constant velocity, but the velocity, see, the slopes are constant, doesn't mean that the value of this slope is constant, right? Maybe the 0 to A position where you have a different slope. So 40 by 10, right, is like a 4 meter per second kind of a slope here. Look at here. So your x difference is like 40, and then but your x difference is like 40 minus 0 is 40, 50 minus 30 is 20, 40 by 20. It is nothing but a 2 meters per second. So the constant velocity, but the velocity value would be the different. That is how you have to read. I hope you are clear. Let's look at next problem. Let's look at this graph. This again a position time graph, but you have to interpret, try to understand like what each transition means. We have 0 to A to B, B to C, C to D. Let's assume that you are walking from your starting position. Then this is how that curve representation for your walk. Now how do I read this graph? Let's say 0 to A. What is happening? Your position is increasing, your time is also increasing. That means you are walking, is it? So how much you are walking? 40 meters. In what time? In 10 seconds. So OA basically tells you a man walks 40 meters away in 10 seconds from starting position. From 0 to A, your travel distance is 10. Your walking distance is 10 meters in 10 seconds. 40 meters in 10 seconds. So this is described clear. You look at this graph. I said right, this is a going upward direction. So it means like x and t are increasing in order. You are moving away from starting point. That is how you have to represent it. Now AB is a flat. There is no change in position. I think sometime you stay at that position. So time interval, if you look at 30 and 10, right, delta. 30 minus 10 is 20. 20 seconds you are at same position. You are at rest. So AB means at rest there for 20 seconds. That's what is given. You clear? Good. Now from B to C, downward direction, right? So what this means is that you are approaching back. You are approaching back to home. So walking back to home, maybe the BC means, right? You reached at 50 seconds, right? At 50th second, you reached home. So the speed probably different, because if your 40 meters distance you are covering in 20, right? 50 minus 30 is 20 seconds. So while you are going, I think you took 10 seconds, but you are coming, you are taking 20 seconds. So 40 by 10 is your velocity, and then here 40 by 20 is your velocity. Clear? And then 50 to 70 means like another 20 seconds. What you are doing? Probably you are sitting at home. That is what it is giving. Are you clear? Very good. So this is an increasing order. That's what I was telling. We have a 40, and this is like a change in position. So dx by dt is nothing but your velocity. Dx is like a 40 minus 0 by 10 minus 0. This is called 40 by 10, means 4 meters per second is velocity. From A to 0 you are going away from the home, and then you have taken your walk speed is like 4 meters per second velocity. Okay, now from A to B, you see your dx is how much? 40 minus 40 divided by 30 minus 10. So it is nothing but 0, no? So you are at rest. That's why I'm saying you are at rest. But what is the time period? This one, this area, So 30 minus 10 is equal to 20. So 20 seconds you are at rest. That's what I'm reiterating. This is a downward direction. So obviously you are coming back. This is a displacement. So x is actually decreasing back. So you are coming back, coming to home. In how many? 50 minus 30. So in 20 seconds you reached home. So what is velocity here? Velocity ds by dt, ds or dx, whatever, dx by dt. So 40, the max point is 40, 0, 40 minus 0 because you're reaching. Time interval 50 minus 30. So 40 by 20. So 2 meters per second. So while coming, you are coming very slow compared to going. Okay, that is what the velocity. And again here there is no change in dx. Dx is a constant. So differentiation for constant is 0. So this is place where v equals 0, means you are in the rest. Where you have rest? At home. Once after reaching home, probably for 20 seconds you are at rest. You are sitting maybe. That's what the man sits at home. That is how you have to read. Look at this graph. Now we shall look at velocity time graph, similar to position time graph. So uniform motion and non-uniform motion, two types, right? Non-uniform is always a curved. You always think about it. When you see the curved nature polynomial equation, then it is a non-uniform motion. For uniform, we'll talk about it. So when you look at this, the graph 1, so with respect to time, the v is constant, right? So that means like there is no change in velocity. So probably it is like constant velocity. So uniform motion. So look at this graph, v increasing with respect to time. So the acceleration is what we get it from vt graph, right? The slope of v and t, dv by dt, is nothing but your acceleration. The value remains same. So this is basically like a uniform acceleration. There is no change in slope. So this is a positive direction, upward, right? It's a positive direction. The other graph you see, this is a downward direction. This means retardation. Slope is a negative. So dv by dt is negative. That means like acceleration is negative. Negative acceleration is nothing but retardation. Okay, this is how you can interpret velocity time graph behavior. Let's look at this velocity time graph and then give me your summary. We know that, right? Velocity time graph is a graphical representation of change in velocity with respect to time, change in time, right? dv by dt is what it will give us. Do you know what is mean by dv by dt? Which is acceleration. So slope is always an acceleration in vt curve. Okay. So from 0 to t time, I didn't really see any change in velocity. Maybe the velocity is a flat. Correct? That is what it is. From this point to A, we can note some point here. What you can give it? Let's say P. So P to A, I have seen that a positive increment and then direction upwards. This is like a positive direction, and then you can also say like speeding up. You are actually going, right? So your dv by dt, the probably some value which is a constant in the interval between interval P to A, but this is a speeding up. If you look at A to B, there is no change in velocity. It's a constant velocity. When you say constant velocity, what does it mean? Change in velocity by change in time. So when you say constant, differentiation for constant is always 0. So acceleration is 0 between A to B, right? Between A to B, you have 0 value. Now look at B to C, downward direction. This is called negative direction. So slowing down, your speed is reducing. You agree? B is like value 40, C is like 0, you are keep decreasing. So your errors is keep decreasing. That's why this is a retardation, right? Negative slope, negative dv by dt is nothing but negative a. So negative acceleration is nothing but a retardation. Alright, this is how you can recognize the each and every segment in VT graph. This basically tells you like how particle travels. The behavior of the particle can be described by understanding the graph. Okay, let's find out the solutions for ask from this graph, velocity time graph. Same graph but asking different questions now. Ready? So who is going to answer? You? Okay. What type of motion is represented by 0 to A? 0 to A, you tell me what is it? First one is, yes, you are right, upward direction. This is an upward direction, I agree. Okay, very nice. Upward direction is also nothing but positive direction, right? Okay, next, and this slope you also see positive slope positive, very good. So what is slope represents? dv by dt. Okay, this is called acceleration, and then slope is constant, so acceleration is also constant. Agree? That is what 0 to a. So it is a speeding up, that is for sure. Speeding up, positive direction, upward direction, yeah, and constant acceleration. Now A to B, what is this called as a flat? This also means at rest, right? There is no change in velocity. So ds by dt, in this case dv, right? dv by dt in this case is 0. There is no change, right? vb minus va, how much? 40 minus 40 equal to 0. So dv by dt is 0, acceleration is 0. Okay, now look at this one. So what type of motion is represented A to B? Is a rest. This is called rest. What type of motion is represented by BC? Downward direction, retardation, right? We talks about negative acceleration. But that is a constant acceleration too, because slope is constant. Find the acceleration of a vehicle during the first 10 seconds. First 10 seconds, how do you get it? dv by dt. Change in velocity between 0 to 10 is like 40 minus 0. So 40 minus 0 divided by 10 minus 0. So 40 by 10 is nothing but 4 meters per second square. That would be the answer. 4 meters per second square. Okay. Find the acceleration of a vehicle from B to C. B to C. So B to C how much? This one. Again, slope 0 to 40 and 50 minus 30. So what you get it? Minus 40 by 20. This means minus 2 meters per second square. So the answer would be minus 2 meters per second square. Acceleration is like a retardation. I hope you're clear now. Now let's look at this problem statement. Velocity time graph for a moving object is shown below. VT graph. So object moving can be described from this plot. So what is an ask? total displacement of the object during the time interval when there is non-zero acceleration and retardation. That was asked. Non-zero. So there is, what is a clue is given? First of all, what is an ask? So when you see this time interval, probably we are not going to consider all the time interval for calculating this problem statement. Second thing what they ask is like a total distance. My God. So how do you understand like how to calculate displacement from VT graph? In the VT graph, how do you calculate displacement? Displacement can be calculated by calculating the area of the VT curve. Area of the VT, right? This is nothing but your displacement. Clear? Displacement. So think about one more thing. So what is this lines actually? This interval. Velocity is constant. So slope of VT, velocity time graph, in which you can calculate a slope, right? So slope is nothing but dv by dt. You look at here, the velocity is constant. When velocity is constant, slope would be 0, dv by dt 0, right? For constant, if you can differentiate the value will get it like 0, right? That's why slope is 0. It is also nothing but your a acceleration. So acceleration is 0 here and here too. You agree? So the ask here is non-zero acceleration and retardation, right? So this case we have to eliminate. What is needed? Only this area. So this area is what is needed for you, right? This is what you can calculate. We can think about this as a two portions, right? So for calculating displacement, you need to calculate area of triangle ABC. You can also calculate rectangle area PACQ. Okay, so what is the time interval here? 40 minus 20. How much you get it? 20. What about this height? From here to here, 4 minus 1, right? This is 3. Okay, so now you see F base 20 and height 3. How much? 2 1s are 2 10s are 10 3s are 30 plus rectangle PACQ, length into breadth. So what is the height here? This height 1 minus 0. Correct? No, 1 and 0. See this one. This is 1 only. So 1 minus 0 is nothing but 1. And hence, what you can say? 1 into multiplied by how much? 20. So 30 plus 20, 50. So 50 meters is what the displacement, which we can get it from VT graph. I hope you're clear. Similarly, we can see now acceleration time graphs. So you have seen these things, position with respect to time, velocity with respect to time, and then now acceleration with respect to time. So acceleration time graph, you see this is a constant line above the x-axis. What this means? There is a flat, right? So when object is moving with a constant acceleration, because this is a constant acceleration, there is no change in the acceleration, and hence this is constant acceleration. By looking at this, you can identify. Okay, look at this one, acceleration time graph, upward direction. This indicates when an object is moving with a constant increasing acceleration. Okay, you are also increasing value. First thing is slope is constant, right? So second thing is like going upward direction. So it's a acceleration is constant value, but going upward direction. That is how you have to read this one. When object is moving with constant increasing acceleration. Okay. Then this one is a downward direction. So constant decreasing acceleration. Whenever you see, you have to recognize the behavior of an object from the graph. Okay. In AT graph. Clear? Now look at these diagrams and let me know your understanding. This is basically giving a perspective of constant position, constant velocity, constant acceleration. So basically this is like a xt graph, right? This is xt graph. This is velocity and time graphs. Velocity and time. So this one is acceleration and time graph, AT. Okay, very good. So we know one thing, position, velocity, how do you get velocity? Dx by dt. Agree? And then how do you get acceleration? A equal to dv by dt. It is very easy to understand basically, right? So if the position a graph, if we can differentiate it, what we get it is velocity graph. Dx by dt, when it is a constant, the differentiation would be 0, right? So that's why this line bringing to the x on x line. So on t curve basically, right? This is what velocity means. Acceleration again, when dv by dt is also becomes, if the velocity is 0, acceleration becomes 0. So dv by dt is 0, and hence you can see the line here. When you look at the velocity and acceleration graphs and the line is on x-axis, this means this is a constant position, and then you can also interpret it, there is no change in x. So x is at rest position, maybe at rest. That is how you have to read. I hope you are clear now. Constant position, how do you interpret the position, xt graph and then vt graph and at graph. Now look at a constant velocity. In xt graph, if you have like a line going upward direction in positive direction, this means like x is increasing, right, with respect to t. But when t increases, x is also increasing. We are moving away from the starting position, right? This is what actually first representation of xt curve. And then if you look at a slope, right, slope of the xt, you get some kind of value, constant value, and hence this graph is known as a constant velocity. The xt graph with a horizontal line starting from 0, origin to upward direction, y is equal to mx graph basically, right? This sounds like a y is equal to mx graph. So you have a constant slope, and hence this is constant velocity graph. Now what you have to see, if you differentiate this line, would become like a constant value. So that's why you are saying. So in the vt graph is a constant line, right? So constant, this, right, v equal to constant. You agree? So this was constant graph in vt. If you can differentiate, this one becomes 0. So your acceleration, change in velocity is 0, no? Right? A is equal to dv by dt. So your constant differentiation should be 0, and hence your horizontal line on the x-axis. This is constant velocity. So constant position, constant acceleration, in both places you see the line is on x-axis for the in the acceleration graph. So there is two possibilities for this graph. Think about that way. Now coming to constant acceleration. Constant acceleration graph in xt, you see this curve nature. If you can differentiate this one, this is a polynomial equation kind, right? So second order. If you can differentiate, you will get a straight line like this. So this is also nothing but a constant acceleration because your slope is constant. right? So your A would be a constant value, some constant, dv by dt. All right, this is one way you can say constant. So because A is constant, in AT graph should be line. This is not zero, it's a constant, some non-zero number but constant value, and hence your graph would be like this. So this is how we need to understand how constant position, constant velocity, constant acceleration graphs look in different context. It means like xt context, vt context, and at context, how these are appears for you. So this is very important concept to understand the given graphs and then answering proper questions. Next problem. A body starts from rest at a time t equal to 0, and the acceleration time graph is shown in the figure. The maximum velocity attained by the body will be. This is the problem given in 2016 bits. A simple problem can be answered. What is this graph? This is an acceleration time graph. Okay, AT graph. First thing, a body starts at 0, right? Rest at 0. That means at t is equal to 0. What you are saying, at t equal to 0, you are saying body is at rest. So initial velocity is 0. That is what is given. Next thing, the maximum velocity attained by the body will be. So how do you calculate this one? So how do you get a velocity first of all in this graph? So acceleration A and time t, at is nothing but your v, right? So this is the area under curve is what is needed, right? So change in velocity is what you get. If you look at it, dv is what you can get it. It means like v minus u equal to area under curve. Area under curve is how much? Half base how much? 11, because this is 0, right? So is 11, and height is how much? 10. So totally how much get it? 2 1s are 2 5s are, so 5 into 11, 55. 55 meters per second, v minus u. But hint is what is given at t0, we are at rest. That means like initial velocity 0. This would be 0, right? So the maximum velocity what we get is this only, right? The answer is B. Clear? Now look at this problem statement. A body moves with uniform acceleration, then which of the following graph is correct? This problem was given in 2012 bits. By looking at these three diagrams, one thing that is very clear for us, uniform acceleration means like a line in AT graph. So constant line is what is given, right? This is a uniform. Acceleration is uniform in this. So obviously the answer would be this one only, C. We have seen so many graphs. Now we are in a position to answer quickly. Next problem. The acceleration of a train between two stations 2 kilometers apart is shown in the figure. The maximum speed of the train is given. So you try out. This is a homework problem for you. You try out. If not, then we will see next class. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. All right. So we reached end of this session. We had a good time, gone through all the concepts of the different graphs and then the behavior, understanding a position graph, velocity graph and acceleration graph and the relation between them two, and then we had solved a couple of sample examples. With that note, I think you should be able to attempt to do the graph problems. So look at a few more examples from your previous question papers, and then build your confidence level. Okay, that's all for today. Stay tuned to next session. I will be uploading this the video into the YouTube channel. Okay, have a good day. See you tomorrow.